Hello everyone and welcome to another lecture of Physiology for Engineers with Professor Gonzalez-Fernandez at Lehigh University. Today we are going to look at lung ventilation mechanics. Therefore, we are going to analyze and dissect all the different mechanical forces that participate of the process in the process of breathing, in the processes of inhalation and exhalation. But before looking at these mechanical forces and looking to all the tissues that participate into this process, I want to focus a bit more on the alveoli. So remember from the previous lecture, the respiratory system with the airways here, the lungs recovered by the pleura, and then the rib cage with the intercostal muscles and also the diaphragm. So if we look a closer look at the alveoli, which are here, so we have the alveoli here. The alveoli are really important because they are the basic units that are going to allow for the air exchange, the gas exchange between our blood and the atmosphere. These alveoli, they are highly vascularized, so they are surrounded by these blood vessels. But in order for the air exchange to happen, we need the atmospheric air to enter inside the alveoli. And this is only going to be possible if the pressure here in the alveoli is lower than the pressure in the atmosphere. So in order for the atmospheric air to enter in the alveoli and perform this gas exchange, we need to lower the pressure inside the alveoli lower than the pressure in the atmosphere. And this is achieved through different mechanisms. So today we are going to focus on that. So the first mechanism that I'm going to, or the first force that is going to regulate this that I'm going to talk about today is the intrapleural pressure. So the intrapleural pressure happens here in the pleura. So remember from the previous lecture that the lungs are surrounded by two pleural membranes, the visceral pleura and the parietal pleura. And these two membranes, they are filled with water. And these membranes, they are going to experience two opposing forces. They are going to experience one force in this way, which is the lung elastic recoil. So the lung elastic recoil is the intrinsic tendency of the lungs to collapse and close down. And then we are going to have another opposed force, which is going to take the pleura into this direction, which is the rib cage or thorax elastic recoil. And these two forces plus the water inside the pleura, they are going to generate a pressure which is called the intrapleural pressure. So this intrapleural pressure is always going to be negative, is always be lower than the atmospheric pressure, and the average of it is around -5 centimeters of water. Okay. So this pressure, this intrapleural pressure is not the same in all the pleura. So we have a gradient. Here is more negative, so here on top will be -10, but then here in the middle will be around -5, and then here will be -2.5, and this gradient is due to the force of gravity. So this intrapleural pressure is going to be the cause by which our lungs, they are always going to have a little bit of air volume. So it doesn't matter how much force we put in the inhalation with our abdominal muscles, that we are always going to have some air inside our lungs, and they are not going to be completely deflected. The only reason by which our lungs can collapse and be totally deflated is by the breakage of this pleural membrane. And this can happen, for example, in pneumothorax or when we have a really bad accident, okay? So then, but our lungs, due to this intrapleural pressure, they're always going to have a little bit of air, but this air is not going to be enough for the respiration to happen. So therefore we need another force to make this happen, and this force is due to the ribcage muscles. So we have two important muscles here. There are the intercostal muscles and also the diaphragm, and they are going to participate in decreasing this pressure, making it more negative, so we can get the air from the atmosphere inside the alveoli. So we have here the diaphragm. So when we inspire, inspire, we get the air. Our diaphragm is going to contract, and it's going to enlarge the rib cage. So, and makes the rib cage larger. So this is going to increase the volume, and therefore is going to decrease the pressure in the lungs. So we are going to get air inside our lungs and inside our alveoli. So if we represent this in a graph, so here we have inspiration, and here we have exhalation, and then here we have the volume in liters. So in our lungs, there's always a bit of air because of the intrapleural pressure, so the volume is always going to start a bit here. So in the inspiration, we are going to increase the volume, making this larger, and then in the expiration, it's going to come down with the relaxation of the diaphragm. And if we compare this to the pressure, so the pressure in millimeters of mercury or also in the centimeters of water, we are going to have, if we increase the volume, we also decrease the pressure in the alveoli, and we are also going to decrease the pressure in the pleura, the intrapleural pressure, and then when we exhale, this pressure is going to come up again, okay? So there is this difference between the pressure in the alveoli and the pressure in the pleura that is going to be equal to the transpulmonary pressure, which is a really important measurement of how good our lungs are in taking air and breathing, okay? So then we are going to go to another force that is really important for the lungs mechanics, which is the lungs mechanical compliance. So the compliance measures the capacity of the lungs to expand when we breathe. So if we have large compliance, we'll have more volume, and therefore we'll have less pressure. We'll get air easier into our lungs and our alveoli. So if we represent here the change in volume, so volume in liters, so the maximum lung capacity is around 5 liters. And then here we represent the transpulmonary pressure. So we'll have this relationship like this, and then here we'll have a slope. So this slope is going to be the compliance that is equal to the change in volume divided by the change in the transpulmonary pressure. Okay. So if we have more compliance, it's going to be easier to get more air. So therefore, it's going to bring down the pressure much lower. So we are going to be able to perform this process of air exchange at the alveoli. And then we have a fourth element that is going to participate into this mechanical process, which is the elastic recoil. Which happens mainly here in the alveoli. So let me clean a bit our alveoli so we can represent it better. And the elastic recoil is the intrinsic tendency of the alveoli to collapse, to be slower and deflate. Okay, and this is due to two different reasons. The first reason is the ECM and the cells, but the most important reason is the surface tension of the alveoli. Okay, so here we have our alveolus. So we have the alveolar cells around it. So inside the alveoli, we are going to have this really thin layer of water surrounded over alveolar cells. And this layer of water is going to generate a surface tension. So the surface tension is going to create a pressure for the alveoli to deflate and close down. Okay? And this pressure generated by the tension is equal to pressure to tension divided by the radius of the alveolus. So this is really important because some of our alveoli are really, really small, especially in small kids, in babies. Therefore, if the radius is really low, the pressure is going to increase, and this tendency, this recoil is going to be really strong, and we have the risk of our alveoli to collapse. But our body is very smart, and for the alveoli not to collapse and for us to be able to breathe, our body generates this surfactant. The surfactant is mainly lipids, and they are going to bring down the tension. So we also bring down the pressure. Okay. So we go now to the last component of the lung ventilation mechanics, which are the airways. The airway resistance. And this is because the flow of air is equal to the change in pressure divided by the resistance. So if we have more resistance, there is going to be less flow of air. And the resistance is regulated by the diameter of the airway. And the diameter of the airway can be regulated in the smooth muscle. So here in the bronchi and the bronchioles, it's probably controlled or can be controlled through the autonomic nervous system, through different hormones and different substances in our blood. And also here, it can also be affected here in the airways, in the trachea and the pharynx and the larynx, through the generation of mucus. So if we have more mucus, there is going to be less diameter, and therefore there is going to be more resistance and less airflow. So the mucus is one of them. That's why when we have sinus, it's really difficult to breathe. And the other reason can also be inflammation. So when our airways are very inflamed, the diameter is reduced, so they close down, and then the resistance comes up and the flow goes down. Okay, so we have looked at the five different forces that are going to regulate the process of ventilation mechanics. I'll see you in the next video. Thank you.